Hello, so we are back, and this time we have a nice laptop to repair. Acer Aspire 3, a classic model. Okay, this is new. I mean, I seen Pentium Gold, and I didn't know what's the story, and this one is Pentium Silver. If you know what CPU is inside, just let me know in the comments, but I think it's first time I'm seeing Pentium Silver. Okay, the problem with this laptop, let's check the customer email. The customer is a computer business. Hello Sorin, hope you are keeping well. Here we have our customer Acer laptop. We came in with no power. On our visual inspection, we notice a burnt chip on the motherboard and believe that's causing the issue. There is a short circuit around it. Please see the picture and let us know if you can help us. Now, let me show you the picture. So this is the picture of the damage. Now, if you think, okay, it's a computer shop, most of the computer shop, they can replace IC. But you see, this is a very tricky case. I mean, clearly the chip is burned. But from what I see here, we have burned layers, which is more complicated for many computer shops. So they decide to send it, and we have to have a look and check. Now, before we are starting, we are taking out the chip, no matter what damage is there, and we are checking the resistance of the coil, yeah, because if the output is shorted, then it's no point repairing this laptop. Okay, so we have a plan. I will say, let's open the laptop and have a look at the damage. And the laptop is open. Yeah, that's a nice motherboard. I mean, check here, yeah? So we have the heatsink here and the fan here. So basically the fan is cooling nothing, it's just, moving the air inside of the laptop. Okay, yeah, it's making sense. So it's taking air from here and it's pushing the air here out. Yeah. Where is the burn chip? Can you spot it? Okay. It's here. Let's go under microscope and check. Yeah, it is looking bad. No, it's not looking like that capacitor is shorted. No, actually the chip is shorted on this case. Now the chip, it's a Synergy chip, AWV, and that's what is matter, AWV. Now let's check the coil resistance before we are taking the chip out, just to be sure. Coil resistance is 15 ohms. Now I can only hope the 50 ohms actually are from the chip, because otherwise 15 ohms is quite bad. But what is connected here? What coil is this? Can be the RAM memory coil. Let's see. Do we have 15 ohms here? No. No, so that coil is not actually the RAM power supply, it's something else. Okay, let's take the chip out. 500 degrees. I'm assuming the chip is welded there. Yeah. It's welded. It's looking bad, but not that bad. Check there. I mean, these tracks, yeah, are all plus, you can see. And that's fine. So we need one wire. Okay, not sure what is here, but it's burned. The board layer is burned, but not that bad. And not sure what is here. Oh, yeah, this is the feedback. Yeah. Okay, let me clean. Cleaning. No, it's fine. Check there. The board is healthy. You can see the board. So the board is healthy, yeah. Yeah, no problem. No, all good. All good. We are fine. Maybe I can, get rid of the welding thingy. Yeah, I can. Yeah, that's good. So actually we can solder the chip here. Possible. Now let's check again the coil. Let's see what resistance do we have there. The coil resistance is 36 ohms. So I believe we are fine. Can I prove that? I can, yeah, I can. But not sure if this chip is outputting a second voltage somewhere. Let me find the datasheet of this chip. Okay, what I found is on our Discord, yeah, so we can search for whatever people ask. So this one is Synergy with 8 at the end. My one is with A7. So this is 5 volts. And what do I have here on the board? I have 3.3. So this chip is outputting LDO. This one is 5 volts. My one from here is 3.3. So I will say I can easily come with the power supply at the output. But I cannot provide, actually I can. I can short the LDO to 3.2 the output, and I will have 3.3 on both. Or I can check the LDO on pin number 15 just to be sure it's not shorted. Yeah, let's do it. So pin number 15 is this one, and it's not shorted. Not sure. This one has 35 ohms. Yeah, this one is the feedback. Yeah. You can see, so from the output, this big track is coming here, and exactly to the chip pin. Yeah. So that's okay. You know what? Let's replace this chip quickly because it's easy. I'm pretty sure I have this chip. Let's replace it. But first we have to find like a brand new chip here. AWV. AWV, check that. A brand new chip. So what do you think about that? It's not brand new? What do you mean it's not brand new? It's a brand new. We're gonna sell this chip as brand new. Check that. It's untouched. Let's do it. So the chip position has to be like that, right? And we can push the chip forward or not. No, we can't push the chip forward, right? No. Okay, that sucks. So we need a wire here. Here you have 5 pins. Then we must have one here. Pin number 1. Let me check pin number 1. Pin number 1, yeah. Some kind of feedback again. Then pin number 2, 3, 4, 5 are all plus. Wait a second. What is pin number 6? LX. What is LX? Actually, it's the output. Wait, so this pin, it's actually this one? Yeah, it is 0 ohms. You can see on the screen? Yeah. Okay, let's do it. Let's do it. So the output resistance is like 35 ohms. If it's the 3.3, it can be the chipset at the output. Then 35 ohms looks good. Now let's get some ROS in there. Perfect. Let's solder this brand new IC. Yeah, perfect. And now we need some proper calibrated wires, right? Solder here. So this pin has to be like that. Perfect. Come on, stay there. Good, so that pin is sorted. This one. That's ground. Then we have plus. And here I will do some kind of bridge, because that's easy. Or maybe we should sort this pin first. Yeah, let's do it. Solder the wire there, then coming with the wire exactly here. A little bit of solder. Good. So pin number 1 has to be here. Perfect. Yeah, so that's the pin number 1. Then we have the other pins from here. Come on. Too much solder? Nah, it's fine. So the other pins are like that. Here, and it's coming back here. Yeah, that's what I want. Like a loop. Perfect. Yeah. Brand new IC. Perfect. Check that. Huh? Let me clean quickly. Just to see what's going on there. I soldered the chip wrong. That's crazy. We soldered the chip wrong. The pin number 1 has to be on the other side. Okay, we took the chip out. This one is fine. These pins are fine. But this one, kind of long. What I did, Okay, the chip is soldered on place. But let's check. This one with this one is not shorted. This one with this one, it is shorted, 0 ohms. We ground 1 ohm. Okay. That's actually bad. Let me take out that pin if I can. Okay, looks good. $38 ohms, that's fine. We ground is 37 ohms, that's good. This pin with plus is fine. This pin with the output is fine. Yeah, everything is good. The final test, right? Yeah. Yeah, let's see if it's working. The plus we ground, I don't remember, I checked. Plus we ground, 3 ohms. How the plus we ground can be 3 ohms? We didn't check before if we have the main power is shorted. Lol, we didn't check. So the main power rail has 2 ohms. Ha, we didn't check that. No, that's not the problem. The chip is not the issue. It's something else. Wait 1 second. So this is ground with plus 2 ohms. No, it's not the chip. It's not my chip. It's something else here on the circuit. And that can be burn layers. You're right. Can be burn layers. 2 ohms. Let me lower the voltage. We didn't check if the main power is not shorted. I can't believe. I mean, how can I do these kind of mistakes? So if I'm looking now back, I never check the main power if it's shorted or not. Never. Okay, let me lower the current. So the plus is here. And it's taking nothing. What? I seen some current. No, it's fine. Checking again with the multimeter. And it's not short anymore. So the short is gone. Can be the layers behind of the chip? Can be. Actually, not behind of the chip, behind of the plus tracks. Can be. Anyway, let's plug a charger. We need an adapter, 19 volts adapter. This one? Yeah, looks like it's this one, but not sure. No. This one? No, actually it's this one. Good. Okay, so 19 volts. Good. Plug in the charger. And it's taking 150 milliamps. I'm assuming the laptop start, or why it's taking 150 milliamps? Because that's bad. Pressing the power button, and it's coming on. Check there, 360 milliamps. And it's switching back. 1 second, switching on 500 milliamps. The fan is spinning. Let me check the output of that coil. Yeah, we have no picture. Yeah, I know. But we reset the BIOS. It is possible. We have to wait a little bit. So the output of my chip is 3.3. The current is changing, and that's telling me a story. Yeah? Let's wait. Let's wait because we reset the BIOS. I seen 600 milliamps, there's 700, 900 milliamps, and the battery is not connected. 1 amp. Come on, give me some picture. The current is changing. The laptop is working. Why you have no picture? Caps lock. I can't see the caps lock working. But the laptop just shut down. No, all good here. It's taking 140 milliamps and that's not normal. We don't have a battery plugged in. We have to find what is taking 140 milliamps. Yeah, that's not normal. 140 milliamps. Actually, we do have a BIOS battery. So no, the BIOS was not lost. And even with 140 milliamps, if I'm pressing the power button, it is coming on. Okay. We have to find what is taking 140 milliamps. What I think is taking 140 milliamps, the LDO from here, probably not, because it's LDO and the EC chip is fine. It is starting the laptop when I'm pressing the power button, so no, probably the problem is not here. Can be something connected to 3.3? Probably not, because the 3.3 is off, right? I mean, okay, the LDO is present, but this one, the big one, no, it is present. So this power supply is on, the big one. Yeah, can be a short here. Can be a short here. But that CPU can be. Okay, let me grab the thermal camera. So with the thermal camera, what is that? Lol, that chip is shorted. Yeah, this chip, yeah, okay, you can see it. Yeah, wow, you can't hold the finger there. So basically, everything what is on 3.3 probably is dead. That's the Wi-Fi card? Yeah, so why that chip got shorted? Because it's connected to 3.3. That's why the chip got shorted, but it's the LAN chip, this one. It's the LAN chip, so normally, you know, the laptop should work, but the problem is this chip is connected to the chipset. And it is possible, actually we don't have picture because of this chip. Yeah, it's a Realtek chip. Okay, let's check first the voltage on this chip. So the voltage on this chip is 0.9. Lol. 1 second. So how the chip is getting hot then? Because here we have 3.3, yeah. Yeah, we have 3.3. Let me remove the chip quickly. So the chip is removed. Who needs network chip anyway? Huh? 2024, everyone is using Wi-Fi, right? Okay, so now if we are plugging the charger, it's taking like 20 milliamps, and that's bad. I mean, why is taking 20 milliamps? 10 milliamps is fine, but 20, it's about double than what normally should be here. Because the screen is gone, because the 3.3 is going also to the screen, this big 3.3. Let's try one more time, pressing the power button, and the laptop it is coming on like before, and the laptop goes off. Huh? Why the laptop switched off? You seen something on the screen, like black thing on the screen? Yeah, I seen it also. So it's taking like 300 milliamps, 500, 600. but nothing was screwed. I mean, the current is changing. I mean, this should be good. I mean, the CPU and the chipset is looking fine. But still, we have no picture. And the laptop switched off. Huh. Switching off is not good also. Okay, let's try to reset the BIOS. Because I didn't try to reset the BIOS. So the BIOS is reset. Plug in the BIOS battery, plug in the charger. Pressing the power button. It's coming on, switching off. I don't have enough current or what? I like 2.3 amps. Yeah. Okay, 3 amps. Pressing the power button and it is coming on. Okay, now it's looking like a brain dead laptop. Or not? No, the current is still changing. Is rebooting because you reset the BIOS? Probably. You seen that change on the pixel polarization? And the laptop switched off. Oh, the laptop is on, but I can't see anything. It's taking like 800 milliamps. No, we don't have a caps lock picture. Caps lock LED. You know, I'm more concerned why this laptop is switching off. Let me try with my RAM memory. Yeah, we do have a power good pin on that chip. But that's not important because the pin is has a resistor to the output. So that pin should be fine, the power good pin. Let me check the RAM voltage. We have 0.5 on the RAM. Wait a second. 1.2 on the RAM memory, and it does fine. The CPU is proper hot. The M2 drive looks good. Probably the M2 drive is dead also. If it was on the 3.3, very possible. What is pissing me off is this laptop, based on the current consumption, looks like a good board. Our 3.3 voltage is stable. Yeah, 3.3. Check that. Now the laptop is taking only 120 milliamps for some reason. Yeah, but if I press the key, the current goes up. You know what? Let me unplug the screen a little bit, yeah? You know what? Also, let me unplug the touchpad. Let me... No, that's all. The Wi-Fi card. No, the Wi-Fi card looks fine. But you know what? Can be. Okay, let me take out the Wi-Fi card, which was on the 3.3, and the M2 drive. Yeah, let's test now. I plug the screen back. The screen is plugged back. And now it's taking nothing, which is good. Pressing the power button, and it is coming on. $100 milliamps. Why 100 milliamps? Yeah, it is 3.3 at the output, it's good. Let me reset the BIOS one more time. If the laptop is charging, of course it's charging. But no point plugging the battery. If I plug the battery, I can't follow the current. Pressing the power button. Coming on goes off. Okay, now it's coming on again, okay. Now it's taking 200 milliamps. You seen that change on the screen polarization? So the laptop switched off. Pressing the power button and it is coming on. It's taking 110 milliamps, which is not good. Okay, let me put back the old RAM memory. This one. And the CPU is off. That's the reason why it's taking no current. Five volts. 0.7. Okay, let me unplug the screen. I mean, if it's working, should work on the HDMI. Pressing the power button, it is coming on. But now it's taking way less current. 60 milliamps. How this laptop can charge 60 milliamps and be working? I mean, probably only the fan is taking that power. Something is not making sense here. I mean, all we did, we unplugged the SSD and we took out the Wi-Fi card. Why suddenly it's taking no current, huh? Okay, let me plug the HDMI. The HDMI is plugged in and nothing. We have picture? That's crazy. How? How we can have picture? Lol, so I was right. I was right. The screen has 3.3 and is burned. So check there. Huh? Oh, actually it's on the HDMI, you can't see. Anyway, we have the HDMI plugged in. So it is working on HDMI. I told you the board was looking like it's working. Yeah. Yeah, the screen is burned. Why is burned? Because whatever was on the 3.3 is gone. Probably even the touchpad. I'm curious. Let me see the touchpad. Pressing the power button. Let's check. Yeah, it is coming on. Loading the windows. Lol. So I spent like half an hour without actually checking with a HDMI cable. No, the touchpad is good. Huh? Okay, so basically only the LAN chip is dead. Yeah, we can. Yeah, we can check. Yeah, we can check the 3.3, the 19 on the screen, but I'm pretty sure the screen is dead. Power off. Yeah, let's check. Let's see. Pretty sure the screen is dead. Yeah. Good. So plug in the charger. Pressing the power button. Let's go under the microscope. So on the screen connector, we have that chip, you remember, which is providing 3.3. I made few videos about that chip, how you bypass that chip. This one. So we should have 3.3 here. We do have 3.3. Then we should have the backlight voltage here, and we have, check that on the screen, 18.9. Yeah. So the backlight voltage and the 3.3 for the displaying part is present. That means the screen is burned. Yeah. Sadly, it's nothing what I can do. I will let the customer know. Yeah, nothing. No, it's. But if the screen is burned and you have no picture, why we have no backlight? Huh? That's a very good question. I mean, okay, you know, the displaying part is gone. But why we have no backlight? So on the backlight, we are using 19 volts from the main power rail and two signals from the AC chip for backlight on and dim. We have PWM signals. Huh? No, this screen is dead. Okay, you know what? I want to check with a different screen. That's what I want to do. Check there. Someone actually work here. Yeah, okay, that makes sense. So someone replace the screen? Let me find another screen. You know what? Something is still bothering me. I mean, like how I said, we have no picture because it's banned, but we have no backlight. And the only reason why the backlight will be off is when you close the lid. And the lead sensor, which is a Hall magnetic sensor, it's on the 3.3 line connected. So I want to find that sensor and check that sensor. That sensor must be near to the power button, but the power button is on the, yeah, okay. The power button is on the keyboard. So the lead sensor must be somewhere here on the other side of the board. Okay, you know what? Let's take the board out. I'm pretty sure that sensor is dead. Because otherwise I cannot explain why the backlight is missing. Apart from, a dual fault on the screen, which nearly impossible. Yeah, let me take the board out. Yeah, the board itself is quite simple to be took out. And probably that's the lead sensor, right? That one? Yeah, must be. It can be on the touchpad also. No, must be this one. Let's check. Let's be sure. So it's looking for you like a lead sensor? Let me plug the charger. Yeah. Let's see if it's working. How we are testing a lead sensor. So the power is plugged in. And we have here, what do we have? Nothing. Here we have 3.4 volts. And here we have 3.4 volts. Okay, that's fine. So when I'm coming with a magnet, I do have a magnet here. So I'm assuming this is the output. 3.4 and the magnet close, nothing happened. And here 3.4 and the magnet close and it's going to 0. Lol. So the lead sensor is good. Check that, it's going to 0. Okay, that sucks. The lead sensor is good. That must be the screen. Let me find the screen. Or maybe I have the same laptop so I can check the whole screen assembly. Yeah. Okay, I don't have the whole assembly, so we have to open the screen and check. I do have another screen. Okay, that kind of sucks. The screen is stuck with these rubber thingies. We have to take them out. Means no one actually opened this screen. Good. Okay, so the screen is out. My screen is though not good. My screen is not good. Anyway, if the screen is open, let's check the inverter. Let's see why the inverter is not bringing the backlight. Okay, so we do have access to the inverter. I'm gonna plug the power. Plug in the power, pressing the power button. Good. Let's check some voltages here. Yeah, we do have a fuse there, you can see it. Probably the fuse is good. Yeah, we have 19. And at the output, we have 18. Yeah, that's good. Then that means the signals, the PWM and the backlight on are missing. So here you have 3.3. Yeah. Then we should have one more resistor, this one. And here we have 18. No, not that one. Huh. Then not sure which is. No, the inverter is off. Okay, we found it. So check here. We have LED enable and then LED, the PWM. Yeah, so we have to check both signals. So the laptop is on right now. And here we have 0. Wait. Okay, now the laptop is on. And here you have 0.7. And the PWM, we have 0. 0 and 0.7. Now, why is that? Huh? Why you have 0 volts on both? Anyone knows? No one? Okay, I will do, but I can't do. Lol, I can't because I'm using the power supply. Okay, we need a battery. We need a battery. Let me plug the battery. Plug in the battery, and the laptop should charge fine. Let's see if it's charging. Yeah, the current is going up. Probably the battery is very low. Let me lower the voltage. Yeah, plus here. And we can't push current into the battery. Yeah, we are pushing 3.2 amps into the battery. And the battery has no problem with that. That should be enough. And now, wait, now we need 19. And the battery charging with 1.3 amps, and we have the charging light. Good. Battery voltage 7.4 and is going up. Okay, I will wait a little bit for the battery to take some current. And then I can use the power supply to supply 3.3 to the PWM and LED on. Let's see now. So pressing the power button, unplugging the connector and it's working. Let me lower the voltage to 3 volts, 3.3. I'm plugging the charger because I need the ground. I'll take a tweezer, yeah, this one, lower the current. Yeah, we don't want to burn the IO chip. Good. And I'm coming with a 3.3. Exactly there, if I can see, but I can't see. Exactly where? I found it. Exactly here. Here and here. And we still have no backlight. Okay, that's unexpected. So basically the inverter is dead. The laptop is still on. Yeah, it is still on. It does not even matter if the laptop is on. I'm coming with the voltage at the inverter. Plus 3.3. It's like 70 milliamps. Let's see, the AC chip is getting hot? No. No. Probably the 70 milliamps is taken by the inverter chip. Possible. The screen is dead. The screen is dead 100%. So what we are doing? 100%, we both signals and 90 volts on the inverter, we should have backlight, and we don't. So I believe this screen has actually 2 faults, which is very rare, and I don't understand why. Initially I thought, you know what? The output is no switch from the HDMI to the screen port, and that's the reason why we don't have backlight. But the inverter is dead. Even if I'm supplying the voltage with the AC chip it's meant to supply, I still don't have backlight. You see, that's why it's bad to don't have parts. Yeah, just think, if I will have a new screen now, quickly, swap the screen and test it, but I have no screen like that here. So I can't test it. I can get a screen tomorrow, yeah. Even today, lol, yeah. I will send Diana to the computer shop I worked before, so she can bring me a screen. Yeah, that's perfect. Yeah. See you soon. Okay, so Diana went there and she could not find any good screen. But she found 3 crack screens. I mean, same connector, same model. And that's enough, yeah, because we can test the theory. If the screen is faulty, yeah, proper cracked, you can see it. We can see if the screen is faulty, and I'm right. If I'm right, then, it's the computer shop problem to replace the screen, actually. So let me unplug the battery and plug the screen. Battery unplugged. And the screen is plugged. Let's see. Plugging back the battery, pressing the power button. We have backlight. What did I told you? I told you. I can't go wrong, you know. You need three signals for screen to be working. Picture, probably we can't go get picture on this one. Let's try different screen. I was 100% sure, yeah. Actually, and you'll ask now. Okay, sorry, but why? If the screen was faulty, why the signal was missing, like LED on and PWM? Because that screen has two faults. One is the picture, one is the backlight. And the screen was never open. This is just a strange coincidence. But because the screen was not detected, the AC chip will not switch the signals on. Or because it was taking like 70 milliamps, then that can explain why the voltage was missing. Wow, we solved the mystery. No, this is our screen. Yeah, that's our screen. Check here. So this screen is open. They are not fixing the screen. So this screen is open from the time I worked there. Yeah. I'm pretty sure about that. And it's open because probably the backlight is not present. Otherwise, what's the reason I had to open the screen? Well, let's see. Okay, the screen is plugged in. Pressing the power button. And yeah, it's no backlight. You can see that. Yeah, that's the reason why I opened that screen. Yeah. No backlight. And this one is open also. So I'm 100% sure I opened this. I opened this screen. I took the cover out, and probably this one doesn't have backlight also. But let's see. Plugging the battery, pressing the power button. No backlight. I knew it because otherwise I will have no reason to, to get access to that board. Yeah. Mystery solved. One second, but I do have a screen the same, like I can move the inverter chip from one screen to the other. So this is our screen. And this screen is the one which is working but is cracked. It is possible to be the same board. Huh? What do you think? I mean, you know what? It will not even be helpful because we don't have picture also. Well, let me check. No, it's not the same. It's not the same. No, it's not the same. It's different kind of board. But we proved the point, actually. The issue with this laptop right now is the screen. Let me plug this screen one more time. Screen is plugged in. Battery is plugged in. Pressing the power button and it's coming on. And we have backlight. Not sure how can I figure it out about the picture. Well, I'm pretty sure the picture is present if it is backlight. Pretty sure the picture is present. Let's see if the pixel, kind of are changing. You can see the lines. I'm waiting for the windows to be loaded up. Yeah, check there. Check there. You can see that line? Not sure if you can see it. When I'm pressing the power button, the enter button, check. No, here, not that one. Here it's a line. Not sure if you can see it. Pressing the enter button and that bar is going off and now it's on. That means this screen, the laptop is displaying the picture. That's what it means. Let's plug the Wi-Fi antenna. And what I can say, I'm happy I helped the customer. I will let the computer shop knows if they want to replace the screen or if they want me to replace the screen, and that's fine. Now I know the laptop is good and I can, order the screen. Good. So I'm gonna stop now. Check here. Check here. 1 hour and 32 minutes. Definitely not worth the, the time. But sometimes when I'm recording, I'm just keep going. Anyway, hopefully this video is helpful for you. Yeah, we went through the all stages. I'll try to edit less as possible, so you can, see how we can approach a fall like this. And this was a tricky one. I mean, we fixed that power supply, and was not working. Was no picture on the screen. It was coming on, and no picture on the screen. Then we found this chip which was getting hot. And what does mean? That's very important. What does mean? Does mean the voltage goes on the power rail, on that power rail, more than 3.3. And if the power goes over 3.3 means something else can be burned. And that's how we found actually, the screen is dead. But this, one more time, this is strange. The screen has two different faults. On the screen, you have separate picture and backlight. Yeah, it's separate, have nothing to do one with the other. And both parts were faulty. Yeah, I would say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.